1,
2,
3, let's go!
I have something to tell you. Your mother has wanted to kill you. Or at least part of her has. In pregnancy, we normally like to think of the mother's womb as a safe and nurturing environment. But in reality, it's a war zone. My name is Lauren St-Germain, and I'm a PhD candidate at UBC, and I study reproductive immunology. In reproductive immunology, we study pregnancy and fetal development, the immune system of the mother, and the placenta as a mediator between these two worlds. Today, I want to share with you this fascinating field. So, what is the placenta? Other than something that some people choose to make into pills and red smoothies for nutrients or good luck, the placenta is a unique organ found in the mother's womb, and it's crucial for fetal development. It's responsible for mediating the transfer of oxygen and nutrients from the mother to the fetus. To illustrate the importance of the placenta, without the placenta, we would not have babies. So the placenta is a very important organ for pregnancy, but how does it interact with the rest of the mother's body? To explain this, first I want to give you a little crash course on immunology. Human immune systems are primed to attack any and all foreign invaders that get into our bodies. The immune system is like a special army of cells, fighting off things like viruses and bacteria. This is how our bodies fight off colds and flus. To give you an even better understanding of the immune system, I would like to describe how the immune system acts when faced with two medical conditions. The first condition that you might know about is organ transplants. Patients receiving organ transplants often need to take drugs that suppress their immune system. Because the immune system recognizes that an organ transplant is not from the patient's body, and it wants to reject it, to kill it. A second medical condition you might know about is cancer. Cancer cells are mutated, and so they grow abnormally fast and can sometimes invade into other areas of the body. Some cancer cells lose their IDs and are able to escape the immune system. However, immune cells do kill a lot of cancers because they look different and they're not healthy. Now, I'd like you to think about the placenta. Although it resides in the mother's womb, the placenta is not made from maternal cells, it's made from fetal tissue. The placenta is foreign to the mother's body, and in this way it resembles an organ transplant. Also, the placenta is rapidly growing and rapidly invading into the mother's womb to supply nutrients to the fetus, almost like a malignant cancer. I like to use the analogy that the womb is a war zone. In this analogy, the placenta is like a rapidly growing, rapidly invading foreign army of cells that the mother's immune system could find quite threatening. One would think that the placenta and fetus should be obliterated by the mother's immune system, but they're not. So how is it that the placenta and the fetus survive? How does the mother's immune system distinguish between good and bad? And how does it know what to tolerate and what to kill? And in my PhD, I've had the opportunity to learn why this happens. The interplay between the placenta and the mother's immune system is beautiful and fascinating. In pregnancy, immune cells protect the womb. There are three major types of cells that control the placenta-fetal interface. The scientific names of three major immune cells are macrophages, regulatory T cells, and uterine natural killer cells, but I'll call them peacekeeper cells and guard cells. Peacekeeper cells negotiate between the placenta and the mother's immune cells, telling the immune cells to allow the placenta to grow and to thrive. And the guard cells help the immune system to distinguish between good and bad. Cells have proteins on their surface, which are basically like an ID badge, letting the guard cells know which cells belong and which don't. In an organ transplant or in cancer, guard cells see that they either have the wrong ID badge or they lost their ID badge, and guard cells kill the organ transplant and cancer cells. But the placenta is unlike an organ transplant or a cancer cell because although it doesn't have a traditional ID badge, it has two badges, like someone with two nationalities. One is a foreign badge, saying that they're not from the mother's body. And the other is a special ID badge that grants them immunity, like a diplomat or an FBI badge. The guard cells in the womb see this FBI badge and they calm down. They don't kill the placenta cells. Meanwhile, peacekeeper cells also see the FBI badge and communicate with other immune cells in the vicinity in the mother's womb, telling them to leave the placenta alone. Many people describe the placenta as a tree of life, as it's made up of branch-like structures and provides the life force needed to grow a fetus. The branches are how the placenta interacts with the mother and how it gets food for the fetus. And these branches each contain fetal blood vessels. The placenta grows and invades into the mother's womb, and at the same time as the placenta's branches are invading into the mother's womb, the womb simultaneously changes its structure and creates pools of blood that the placental branches bathe in. In this way, the placenta acts as the interface, where the fetus's blood supply and the mother's blood supply interact without ever touching each other. In my PhD, I work specifically with the cell I've been calling a guard cell. It's actually called a uterine natural killer cell. And these cells only exist in the womb of a pregnant mother. They're really neat little cells, and they're much more complex than just being guard cells. As you know, the guard cells tolerates the placenta and the fetus as long as they have the proper ID. But he also has another part-time job. He's also a nanny to the placenta. So in addition to being guard cells, they are also responsible for helping the mother's womb during pregnancy. They do a lot of cool things to help the placenta, like eating away at linings of blood vessels in the womb, allowing for blood to flow more efficiently into the pools that the placental villi bathe in. They also send out signals to grow new vessels into the womb, and this helps the mother build placental infrastructure for a healthy pregnancy. In my opinion, these guard cells are very important for pregnancy. With this knowledge, you may be able to better understand some common pregnancy complications. When there is an imbalance between tolerance and killing, a pregnancy is less healthy. And if the guard cells and peacekeeper cells don't do their jobs to promote tolerance of the placenta, or if the guard cells fail to do their part in helping the womb remodel, there can be serious consequences. Some of these consequences include fetal growth restriction, preeclampsia, preterm birth, and even fetal death. What you might not know is that we still know so little about pregnancy. Historically, there has been a lack of funding and attention for learning about reproductive health. In 2019, the NIH funded research into pregnancy 10 times less than research about aging, and 12 times less than research about rare diseases. And I'm not trying to say that research into these diseases aren't important, but think about this. We were all once a fetus in the womb, and we are all born of a mother who was pregnant. But we still know so little about pregnancy and what can go wrong. In 2014, the NIH launched the Human Placenta Project because they finally recognized the gap of knowledge about pregnancy that we need research to fill. The NIH Placenta Project was founded on the basis that the placenta is arguably one of the most important organs in the body, and it influences not just the health of a woman and her fetus, but also the lifelong health of both mother and child. Their goal is to understand placental development, function, and structure throughout all stages of pregnancy. Researchers, including myself, are trying to know more about reproductive immunology with respect to the placenta. And our lab studies a variety of topics because what goes on in the womb is so complex. We study how placenta cells change as they invade the mother's womb, and how the placenta and the immune system interact differently in conditions of inflammation or obesity. The things I've learned during my studies wouldn't be possible without the help of my amazing lab partners. We need people like those in the picture that love to learn about the interactions between a guard cell, a peacekeeper cell, and the placenta, because we need to do more research to provide successful medical interventions in at-risk pregnancies. I invite you all to think about pregnancy in a new light today, as a fascinating field full of undiscovered knowledge. And after you leave this event, to talk to your friends about the biological wonder that is the placenta. And most importantly, I would like you to go home from this talk remembering one thing. The womb is a war zone, and it's a miracle we are alive.